Hi guys, thanks for having me. So today I'm Wilson Mendes. I'm from Brazil. I have a different accent in my English, so it's a mix between Brazilian and English and Australian English, which is totally different. Trust me. They call beers big ears. Don't ask me why. And today I will talk about front-end evolution on first wagering web app in Australia. First of all, let me ask something. Who here knows what wagering is? Great, because we were on the same page. We don't have this concept in Brazil. So when I start working as consultant for this company, I just realized, what are we talking about? But it's pretty much betting. If you put some money in something, could be a sport competition, could be a competition, could be a racing. You put some money in anything that you can win or lose. We are talking about wagering. We are talking about betting. Just a quick overview because I know that this could happen. But first, I know that you guys can't see that, but this is snow, and you guys have no idea what that means to me. And first of all, I never seen snow before. So just realize me. I was running outside looking. Is that true? Yeah. It's embarrassing. So let's start. Once upon a time. We always have to start a story like that, right? So that's the company. It's called Tabcorp, and all those brands are part of the main company. So what's the goal with them? They have a web application, totally component-based. That's something that we probably are not familiar with the names, but we are using. For example, when you go to when we access Netflix and try to see some videos, we are using component. It doesn't matter if we're accessing via TV or via web app or via web application. We are trying to use the same component everywhere. So they tried to use the same idea, but they were failing in some points. And that's when we start the story. We were using all those technologies, call script, npm, private repos, and grunt, karma, docker, and all some cool tools. But when we start, first of all, this application starts working in Australia. And we had a scenario that we had to use the same application with different rules, different business rules, different laws, because we had to run the same application in UK. What if we need to add that? What should we do? Because now we have a code totally coupled with our rules, the rules based on the country, and we had to reuse them. Even if you look at the website, that's the current website that we have, the Australian one, tab.com.au, and that's the Sun, Sunbets. Sunbets is a brand from the Sun. It's a UK newspaper. It's pretty famous there. And if you look, let me go back, you can see that we have some components that are pretty much the same behavior, some things different. For example, here we have a button that we can see all the bets that we're doing. And here we have one called bet slip. And we can reuse everywhere. So it's pretty cool. But it was hard to maintain. It was hard to evolve. We were talking about an application that starts with Angular 1.2. And this was a scenario that we had last year. If you guys already had that feeling, it's not that easy. Test was really hard, and scale were really bad. It was something like that. You were playing with a dinosaur. Looks good, looks really cool. It's fantastic when you see, but you know that something bad will happen. So okay, what we can do? Let's separate some concepts. Why? Because it's easy to maintain. If you don't need to know about the whole application, for example, just realize I was there and I never went to a horse racing, or something like that. If I don't need to know things that I don't need to handle with, in that moment could be better. So it's easy to maintain. It's easy to test because you need to know about the whole world to test your application, and easy to debug as well. So let's think in small pieces. The first one is one thing that they call level score. The text is pretty small, but what we are doing here is, okay, we have a competition, let's say Russia versus Ukraine in volley. I saw that yesterday. So let's say it was 12-13, but it changes for 13-13. And this will be changed in lifetime, in real time. But it was a big bottleneck. All this domain, all the logic in this component was in the clients. And if we're talking about clients and web clients and mobile clients, this is not helpful. Because if you have to change something, you have to do 2 deployments, and release for mobile is not so simple. Not enough test scenarios, which is pretty hard. We found a lot of bugs in production, which is really bad for the user, of course. And it was a coupled code. What we can do? Sacrificial architecture. What it is? Let's think in you have the whole application, and you need to do support for both places. So you need to think, okay, I have to evolve my application, but I still need to give support for the old one, because we have mobile, and mobile is not that simple. As I said before, we have releases, and you can't just, okay, let me drop some information, add new, and that's it. So you need to keep support for both for some time, and after that you can remove the old support. So some problems to solve. Support all the new clients, because we have this scenario. We had to remove the logic from the client. That was the main goal, because if we have this goal finished, we can easier just deploy, for example, deploy our API, and we have everything up to date for mobile and any other client. So we start with API first. If you have everything on the API, you don't need to care about web and mobile. You just need to care that both clients should be stable and should be ready when you change something. So it's pretty useful. Another thing that is on top of our minds is provider, which on front-end is a kind of one thing that you almost never heard about it, because people are not so familiar in some moments for those things. But let's show us a small example. We have this guy, this component that we call affiliate links, which is pretty much, okay, we have a bunch of images. Let's see if we have another scenario. Here, bets, so some bets. Another one, casino. Let's say that we had one only for UFC. This is a small component, pretty simple, pretty straightforward, just a link and an image. But a way to make it coupled is, okay, let's do the first one. The first code, we have a configuration. So we can easier just set up the information that we need in the bootstrap application. We can set the image, we can set the address, we can set anything that we need, and we can use the component. The data is there. We can use it the way that we want. And our template will be really simple. Sorry. You guys at the bottom, can you guys see that? Oh, okay, great. Thanks. So here we just need to access some methods. If you look at the code, here we are talking about an AngularJS application, but the concept doesn't matter. If you're using Ember or React or any other library or framework, you can use the same concept, because you are just handling with data, which is not bad. If you think about it, you can reuse your components. You can, if you have to add a new image, you don't need to do a new deployment, because you just handle with data. a small win. And why we need to do those things, why those things can be helpful. First of all, stateless components. There is a big one. For example, if you don't need to handle with data, you don't need to transform in data that you're receiving, your components are kind of stateless. You just need to grab that information and render the way that you like, for example, for tables, for small components, like input or any other form, you can try to do stateless components as soon as possible, because there are some that you can't. It happens. And it was a main reason why we had to upgrade to Angular. First of all, performance issues. When we have a lot of things to improve, it was not that easy. And Angular had a lot of best practices and benefits in this movement. And we are talking about components, right? Components should be pretty much plug and play, like this. You don't need to care about the logic itself. Don't need to care about anything. It's just a black box. Okay, I send some information, I'm receiving something else. That's what I need to know. I don't need to know how the things work internally. And if I need to know a lot about that component, there's something wrong. Another point, performance issues. It was another big one. And the most problematic component was that one, which is pretty small. But what it does, what this component does, it grabs the information and renders as a table. But it was with a bunch of logic inside. So if you had 1,000 information, you had to render all those 1,000 in the client, which is why we are doing this. And didn't have any track, any loop. So what's the difference of this for this? Looks really small, the numbers between one and another. And gRepeat timer is 2 seconds, and the other one is 4 seconds. The difference between both, and this logic is not applied only for Angular, it's applied for all front-end libraries and frameworks. If you have a component and you're passing some data, but you're not saying anything about the indexer, let's think like a DB. If you have a database, you have information that, but you don't have any ID. If you had to do a search, it would take more time than if you had. It's the same for the component as well. And the problem in front-end is even worse, because the component doesn't understand that you're changing the information and understands that you're changing the component itself, which means that 1,000 of information in real time, changing every time, they will be removed and added again. So instead of change the data, you're removing the elements from the DOM and add them again. So a small example of what was the impact of this scenario. If you go to some browsers, they just break after 3 minutes because of some memory leak. Yeah, it was interesting. Another tool that helped us with that was Lighthouse, which is pretty useful. If you think in PWAs and ways to improve, it has a really, really good report. It's really beautiful as well, readable, and you can see points that you can improve, how can you improve, and how to make your web application better. Another point, tests. People usually don't talk about tests. Don't ask me why. But we had a bad scenario as well. Why? Because since the code is complicated, test then is complicated as well. So what people do when something is hard, they just stop doing. It's our behavior, unfortunately or fortunately. That's why the reason that we need to be lazy people. Okay, how can we test? If we know that just for test one small component, you need to pretty much do a setup for the whole application. This is not useful. Another point is what we need to test. Think that we have a small component that has a lot of dependencies. What do we need to test in that scenario? How can you split that small pieces? Think about behaviors, think about logic, and how can you maintain that? So that's a scenario that we had when we start. It was 8% of code coverage. And we usually had some production issues, pretty much daily. And after that, we just realized, okay, we have to improve. There's another chance, and let's do that. First of all, if you're in a scenario in your company or any other place that you don't have any tests at all, which point do you need to start? The point that's more painful. Painful thing in business. Let's say if that button is not showing, your company is losing 30% of the whole money. Looks weird, this scenario, but it happens. I had to work in a scenario like that. And find at your first pain point, work on that one so that you can share the benefits of doing this approach. Create the scenario for this one, that small piece, and try to avoid hard setup for those things. With that, as a small example, we can see what this component does. That was the first code. It's another thing. You can see something like has any is true, all is a list of all registered links. But what that means if you don't look the code? Can you guys have a shot? Exactly. Nobody can know what are we talking about. So that was my face. So after some changes, we had this scenario, which is pretty readable. So you can understand, okay, given we have something available, you need to expand. Just to clarify, we were talking about an expandable component. So given we have something available, we have information available, should expand by default, which, okay, I don't need to know the internals, but at least reading the test description, I know what we're talking about. And we did this in some other places, which was good, because we start testing by behavior, not for function return. If you have a Boolean like, okay, it's true, it returns me a true or false, it doesn't matter to me. But when I know the behaviors that the component should do, the behaviors that the application should do, it's easy to validate and easy to understand. And more than this, you can refactor. We can encourage refactor across teams, which thinking in a distributed team can be really useful. And other thing is transparency. Usually, another problem was, okay, we have a lot of dependencies. This component needs this other component, and this another component. And how can I know if they are breaking or not? So I created this guy called build checker app, which has this interface. And you can see, okay, I have some tasks and validations running now. They are running, they are broken, or they are okay. The test passes, my validation passes. They are ready to production. And it's pretty much visible, so if you have any issues, you can easier just go there and work with them. And after those things, we changed the scenario from 8% to 72% of code coverage, which is not the best one, but think that all those things happen in 3 weeks. It was a pretty cool one. And still talking about testing. Async code on tests that we are not talking about. Async code is pretty much tricky, and this is the best image that I could add when we are talking about. Okay, we were running the tests on Linux, which is a Unix, and TOAD has parallelism by default built in. So why not use this in our just for us. So before we start the test, before we start the validation, we just, okay, if you have 4 cores in your computer and you can use them, just use them. So we change the behavior that before was 13 minutes to 6 minutes. So we decreased more than 50%. It's still not the best one, but it was a huge win. And another decision that we made was moving from Travis to BuildKite. This was more related to some laws that we had in Australia. They had to create some things built-in on the company, and BuildKite has some agents so you can easier bring some computers, and okay, you will be my agents. You just need to do a quick setup that's less than 3 minutes, and problem solved. So you can, some of those setups were build the artifact that we need to send production, and the whole integration. This is one of the integrations that we have. We had this before Heroku released this feature, which is pretty cool. What that means, okay, I'm in the application and I create a branch. I just need to do a quick test. I create a branch and I send my branch to from GitHub. When I send that, in 3 minutes, you have the whole environment up to run. And you can do your test validations anywhere. When you finish that, you just remove the branch and that's it. Problem solved. You have the whole setup easier, and we don't need to know anything. Just, okay, I did this small change, but there are some things that I'm not that sure, and I need to validate internally, externally. So it was easier. So since it's easy to test, it's easy to deploy as well. So another point. After we did all those things, we just realized Melbourne Cup, which is, for who don't know, Melbourne Cup is the #1 competition in Australia, which means 70% of the whole money that the company does is related to that day. And we had one scenario with 15,000 concurrent users and 117,000 of concurrent users only web and mobile, because as I said before, we were using components everywhere, which means that we are using components on TVs and totems and any other device that we can have. And we had the response time in 30K per second, which is really interesting. 0 downtime. Another thing, all the concurrents had some downtimes during the main competitions, so they were losing money in those moments. And another thing that we are not talking a lot about is changing with organization. Change the organization, the way that we are doing some things, the way that we have our mindsets. First of all, they were trying to experiment some things, but they were not able to. So first of all, let's think which tools and which approaches that we can have here, we can experiment. And we found the tech radar from ThoughtWorks. So we just create our call it Tab Corp radar. And we add some points. Okay, these tools we need to use, these tools we need to avoid, and these approaches we can use, we can keep using. We need to experiment this novel language or novel tooling or even another way to work. Another thing, the company before was splitted between layers, which is not good. Think that you're working in a puzzle, but you don't know what to expect, what can do, what can happen. You just bring the puzzle, put the wrong place, and it doesn't fit. Okay, if you're working in a company that has, let's say, e-commerce, you have the basket, you have the payment information, you have a team for payment, right? So why not think that if you're handling with mobile, if you're handling with web app, put everyone who's involved in only one place, only one team. A small one, but totally with the ownership that's required. That's the way that Spotify works. It has small squads and tribes. Cool names, fancy names, because they can, but it's pretty much small teams in a main domain. If you're thinking in self something, but you have small pieces, you can split and release fast. That was the main goal. And after that, we finished with that. We moved from Angular 4. And we just realized one thing, divide to conquer, which means Strangled Pattern, which is pretty common, but it's another fancy name. Who here knows about that? Cool. Strangled Pattern, time to understand things with Will. So Strangled Pattern came from the idea that it has a tree called Strangle tree. Funny enough, it's in Australia. And what it does, you have a big tree, it just born inside the tree, it starts to kill the tree outside from the inside. It's a kind of virus. But how can you use that? Let's think that you have the whole application, you need to move, that was our case. Application with, I don't know, 50 pages. You can't do a big bang, right? So how can you handle with that? If I can't do the whole migration in only one shot, why not do page by page or piece by piece? That's what we are talking about. We usually do that, but we don't know the name. That's the name. And which came with another name called micro whatever way. Yeah, because we have micro page, microservice, micro whatever. And what that means exactly. I will talk too much, so let's see something working. This is a pretty dummy website, right? I just didn't add any fancy CSS or fancy framework. It's just a server-side rendered web page, because here we just need to see the concept right now, right? And another thing, we have some blockers. So I was scared to put something and didn't work. It's not cool. We can see in some Microsoft applications. And yeah, let's see that that's the home page of our website. And we go to the first page. OK, that's our cool first page. Let's see that this could be our e-commerce. So you can see a list of information, add them, back to home page, go to your second page, which can be your payment one, and back again. Cool website, right? But it's using that idea of micro frontend. Let me show you guys. Can everyone see those folders? OK, apart from Nginx folder and assets folder, all of them are those pages. When we are accessing home page, this page, we are accessing this guy, which is pretty sweet. And when we are going to first, the other guy, and second, the other guy itself, we have a simple configuration here. It's just a Docker compose, so you can, every single page, it's contained, it's self-contained. So you can go here, OK, this will be the name of my container. I need to build like that. And you can add one by one. And for example, that's the code that we have for the first page. When you access first, just render the page. If I had to change something, in that page, I just need to come here and let me change something. So in that case, I can add features, I can remove features, I can refactor something. I can refactor something and nothing breaks. And it's easy to set up because we are using Nginx, just a reverse proxy. When every time you access this address, you're being redirected to another one, another page, which is our page. For the user, that's totally transparent. We have our address, and when we click, we change the address. And for the user, it's simple. For us, it's simple. You don't need to do a huge deploy or a huge big bang if you have to improve anything in that page. Right? So we are always talking about microservice, micro frameworks, and micro whatever you want to call, and we want to create because we can create, and we are creating that. Funny enough, we are just creating fancy names for things that we created a long time ago. But the main goal is let's modularize everything. Why should you modularize really everything? A page, a component, the way that you can create your web application, mobile application, or the way that you can deploy something. Next step now is a kind of the challenging one, because we had this migration from AngularJS to Angular, but we don't know the future. They were concerned with those migrations. So the main idea is, okay, what if next year we won't have Angular or React or any one of those frameworks and libraries that we know right now? We don't need to care. At the end of the day, we are talking about the language, which is JavaScript. So if you create something, vanilla.js, which is pure JavaScript, and integrate with your library or framework on build time, you still have the core in the language. And when you're delivering, you can integrate and share that with the user, and decrease the risk if you had to migrate something. Or at least you can decrease as soon as you can. Nothing's perfect, but you can help in those things. And be lazy. always be lazy. We can't forget that, or things like that can happen. Right. So that's it. Unfortunately, sorry guys, I don't know how to say that. I know what it means, but sorry? Spicebo.
Yeah. That's cool.
Spicebo. And the second one is from Australia. Pretty much everything is mate, which is a friend. And the third one is from my main country, Brazil. Obrigado. All of them are the same thing. Thanks so much, guys.
And we have time for questions.
Hello, my name is Artem, to GIS. My question about behavior tests. What do you use to start it?
Okay. In a scenario that we don't have tests at all.
No. What do you use for your behavior tests?
Behavior?
Yeah.
Okay, I'm usually starting with Jasmine. Jasmine integrate with some jQuery features. But it depends of the application. We can use Jest, or we can use any other. You're talking about the framework, or?
Yeah. And how can we count a coverage which is based on behavior tests? I know how to count coverage which is based on unit tests, but how we count on behavior tests, I can just realized.
Okay, that's a language called Jericho, which pretty much every framework is is using. For example, there is one called Cucumber.js, which comes from Cucumber from Ruby. So you can write in a human language, like when I access the login page and I add my username and my password and click the button, they should happen. You write your test like that, and when you run your test, that behavior will happen. So you're writing something, thinking behavior, instead thinking in small things. Is another layer of the test.
It's just a unit test, but we just describe it with another words, yeah?
Uh, Not exactly. We have different layers. We have one thing called test pyramid. So we have unit at the bottom. You have E2E or behavior test, BDT or any other test. And we are going up. Why we have this differentiation? Because, for example, if you have to run a Selenium test, it will spend more time and more resources than unit. But what we did in that scenario was we were writing unit tests, but our descriptions were more based on BDT.
Okay, thank you.
Make sense?